Afternoon, everyone. Before the speaker, I'm just going to introduce Roy's AFIRE project for a few minutes, and this will give a chance for everyone to join us. The Research on Research Institute is a international project with 18 core partners, shown here on the right, many research funders that you will recognise, and together with the researchers involved in the Research on Research Institute, we co-design projects which aim at making the research system more effective, more efficient and fairer. Projects like MetaRaw, which is a new platform for open peer review of meta-research, which is launching tomorrow at the AMOS conference, which anyone who is joining from the other side of the world or up in the middle of the night on this side of the world may be attending. So please look out for that. Projects like the Grail project, getting about responsible use of AI in funding evaluation, and you can expect to hear a lot more about that, including a launch of our Funders AI Handbook at the MetaScience 2025 conference, and you can read the recent report and emerging findings from Grail by following that QR code there. And of course, today's program, which is the AFIRE program, the accelerator for evidence in funding, research and innovation funding. We exist to increase people's awareness and enthusiasm for better evidence in the research system, to build capacity among research funders to generate and use evidence. And we have this is a joint program from Rory and the Innovation Growth Lab, and we have separate project partners, some of whom are also Rory funding partners, which I've shown on the right of this slide here. And we've got kind of three components to AFIRE. We've got the forums where we want to bring people in and showcase people who are generating evidence on the funding system. That's where we are today. We want to work with funders to help them run their own experiments. And then ideally, we want to work to help to provide scientific support on the actual running of experiments. And by experiments, we mean formal evaluation of innovations, not just testing new things, but testing and learning from new things in research funding. We have this program of funder forums, which you must have heard about by definition of being here. Maybe you're watching it on the recording. And so we hope you can catch up and or join us for future episodes of this funder forum. And we're also taking suggestions for new speakers. So, and just finally, this is sort of like the timeline of the AFIRE project. So we're running the forums monthly. We hope to have what we call sprints, which will be intensive pieces of work, meeting weekly or fortnightly over 2 or 3 months to work with particular funders on specific topics. The two leading candidates for specific topics are sort of my first RCT, fundamentals of experiment design, or learning from the science of evaluation in research funding. And there's a lot of interest around new ways of doing peer review and ideation around peer review. So those, look out for announcements and about how to get involved with them in the next month or two. And we are also currently running 2 larger pieces of work. With the Volkswagen Foundation, we have a project advising on their evaluation of distributed peer review, and we are working on a core outcome set to support evidence synthesis in studies of partial randomization, which builds on kind of prior work from phase 1 of Rory. We are hoping to announce in the imminent future new experiments as part of the AFIRE project, and we've kind of set ourselves a deadline for that of the MetaScience 2025 conference, which we hope to see many of you there at. I mean, as by way of kind of feedback to the community, we're kind of lucky enough to have lots of conversations with funders about what they're interested in trialing and evaluating, and a sort of current chef recommends, the specials board, these topics. I mean, we're interested in talking to anyone who wants to use evidence or generate evidence on innovations in the funding system or on any topic, but these are the things that either we have ongoing projects already, or we have very active conversations with funders who want to combine forces and run new evaluations in these areas. So that was a bit of a whistle-stop tour. I'm going to start sharing my slides here so Jordan can take over. We're very lucky to have Jordan Dawkin here, who is the leads the innovation policy portfolio at Open Philanthropy, and was with Alice Wu at the Federation of American Scientists, the think tank where the work that he'll be presenting was done. We, as I have said, we are going to be recording the talk for you to catch up, and then at the end of Jordan's presentation, which I think should take 25 minutes or so, we will stop the recording so we can have a discussion in relative private among ourselves. I think that's all I have to say. Jordan, are you ready?
I am. Thanks so much, Tom.
Thank you.
Awesome. Well, it's really great to meet you all. I think there are a lot of folks here who I've not had the chance to meet and talk with, a few folks who I have. So great to see those of you who that's true for once again. Before I get started, just a few kind of housekeeping notes. One is that Tom very generously just gave me a very significant promotion that will be news to Matt Clancy, who is in the audience, who actually leads the innovation portfolio. I'm lucky to support Matt on that work. Two, as you see from the title of this slide and the mailer that got sent out that invited you to this talk, I was supposed to be presenting with my former colleague, Alice Wu. Alice had to step away for some family reasons, but the fact that I am presenting alone does not take away from the fact that Alice is really kind of the brains behind this project. She was instrumental for kind of conceptualizing the work, implementing it, and summarizing the results that I'm going to discuss today. So please be sure to, in your mind and in any further communications, give Alice her due credit. As Tom mentioned, this work was conducted under the auspices of the Federation of American Scientists, which is a kind of science and tech policy think tank based in Washington, D.C., where I used to work and where Alice currently still does. I am now in the innovation policy portfolio at Open Philanthropy. And in Open Philanthropy, we are really kind of interested in and excited about supporting these kinds of innovative experimentation ideas in science funding. So please, for folks of you in the audience who are thinking about that, which I think is probably most of you given the topic, please feel free to reach out to Matt Clancy, who's in the audience, and myself, just to discuss things that are on your mind and how we might be able to work together. So with that, really excited to talk about this project. I think unlike some of the work that's been presented and will be presented, this is more of a feasibility study. FAS is not a funder, so we kind of were able to de-risk and think about some of these ideas and are excited to talk with you all about potential ways of scaling it up. We call this predicting progress. It's piloting kind of how you could use an expected utility framework in the review and selection of scientific grant proposals. So the setting for some of this work is really just the idea of risk and reward in science funding. This is an idea that is probably familiar to most of you, and I pulled out an example of this being a priority for specifically the NIH, the biomedical funder in the United States. Recently, the NIH put out a kind of request for information on a few priority meta-science related research questions, and one of the 7 top questions that they had was about how NIH should assess risk in its research portfolio, how much risk it's acceptable for it to take as a steward of public funding, and whether the current system fosters risk-taking and encourages researchers to explore high-risk research, and if not, how they might do that better. So those questions are really just kind of the core of what we were thinking about in launching this project. And in addition to kind of NIH's and other funders' general interest in these topics, the literature kind of lays a foundation for thinking that traditional models maybe discourage risk in some contexts, or at least are not optimally encouraging it, or at least encouraging it to an extent that a lot of funders and scientific institutions would like it to be encouraged. So I've put a couple examples here. The top left is kind of a summary of the literature from the website New Things Under the Sun. That's run by my colleague Matt Clancy and is a great resource for some of the thinking and some of the research in this space. And then some examples of specific studies. The second one down shows reviewer preferences for feasibility over impact of studies. The third one talks about contagious negativity in peer review panels, such that if you hear another reviewer on your panel critique a proposal, that will affect your own score negatively more than a compliment from a peer would raise your score, which can kind of create these dynamics that will discourage risk, especially because high risk, high upside proposals might have more surface area for critiques that can kind of create this effect where proposals that are of that category can get kind of dragged down. The fourth is more mechanistic. It just talks about how the structure of scoring in a lot of peer review contexts can just create kind of bunching at the top and can limit the extent to which kind of tail impact can be reflected in scores, but doesn't limit the extent to which like individual very negative reviews can drag scores down. And then one kind of cornerstone piece that came out a couple of years back, or is still a working paper by Chiara, Franzoni, and Paula Stephan, is this one, Uncertainty and Risk-Taking in Science. So this lays out a lot of really interesting frameworks for thinking about risk and uncertainty. But the one piece that I'm going to pull out that was really kind of instrumental for Alice and my thinking in this project was laying out an expected utility framework for kind of how to think about the potential impact of scientific grant ideas. So sorry for the text-heavy slide, but this is kind of just like laying out the difference as I see it between the expected utility framework and a traditional setting. So in traditional settings, when criteria like feasibility and impact are scored, they're usually scored on kind of simple Likert-like scales and then averaged together, sometimes formally averaged, sometimes kind of encouraged reviewers to informally average them. But often these ideas are kind of fuzzily operationalized and can allow, sometimes purposefully, for these ideas to kind of blend into each other and play off each other in potentially biasing ways. So one example is if I think a proposal is really unlikely to succeed, I can justifiably penalize that not only in the feasibility score that I give, but also in an impact score. If I think there's a 1% chance something's actually going to work, then with a fuzzy definition of impact, I can plausibly say that it's not a very impactful proposal. And then you kind of double that probability of success in both feasibility and impact. The expected utility framework that Chiara and Paula lay out in the scientific context, I've laid out a very simple case, but essentially you define a scientific project as having a set of kind of outcomes or milestones that comprise it. And then you can define the expected utility or expected value, in a sense, of each milestone as the product of its particular utility and the probability that that milestone will occur. And then in a kind of toy simple case where the outcomes that you define as making up a project are kind of mutually exclusive or independent from each other, you can get the total expected utility of the project as just the sum of the utility of the individual outcomes or components. This gets a little more complicated in like real scientific cases where milestones or outcomes are often sequential. They kind of build on each other, but there are kind of frameworks and definitions for calculating total expected utility in those cases that you can read in the full report on the website. But just the context doesn't really change. It's just the calculation that does. So with that in mind, Alice and I wanted to kind of think about how this could actually work in a scientific review context. So as I mentioned, we are not funders. So we launched this as essentially a feasibility study where we had a set of proposals that we could already kind of do this with and raised a little bit of funding to kind of bring in peer reviewers to apply this approach. This is the title of the kind of overall report that came out at the end of this project. There are a couple that build up to this report that are more detailed on the methodology or the background, but those are all linked from this one. You're welcome to find them there. There are three kind of components of the pilot that we want to highlight here that we think were kind of contributions. The first is this expected utility framework. The second is that we kind of thought about how to define an impact score that might limit some of the mechanistic biases that we saw in other contexts in the literature. And the third is implementing kind of not only a prediction framework, but a forecasting framework where the predictions that reviewers make can be formally resolved. So I'll talk through those one by one. The expected utility framework, this is the same slide as before. But I just want to call out, like, one of the reasons why we think this is potentially good is really doing that disentangling of feasibility and impact instead of kind of defining them fuzzily and averaging them together. Here, you're really encouraging reviewers to pull out the probability that they think an individual milestone or outcome will be hit. That is very well defined. The operationalization is not unclear. They're estimating probability. Whether they're good at estimating that or not is a different question. And then you ask them separately, kind of conditional on that outcome being achieved, how impactful would it be? So in that case, someone can say 1% chance of that outcome being achieved, but you're conditioning that away when you think about the utility, and you're asking them to actually think whether or not they think it'll be achieved. Like, how important could this be? How impactful or innovative could it be? And then the actual overall value of that outcome aggregates those two in a formalized way. And the second piece is that kind of simple, clear aggregation, where this is kind of a mathematical formula where you aggregate them to create like an expected value, which means something clear in a way that some overall scores kind of take pieces of various criteria without kind of making it obvious which ones are factoring in how. And I think NIH is an example of that, where like reviewers can treat those criteria differently in formulating an overall score, which makes it hard to interpret what that overall score means. And the third is that just asking people to rate these individual components, like probability of success and impact conditional on success, can be really helpful for program managers or program directors or program officers at kind of understanding and sometimes actively shaping the risk reward profile of their portfolio in a way that is potentially a little bit more straightforward with these well-defined measures. So the second piece I mentioned was this impact score. So this plot is from a 2014 paper, and it is kind of just being used here as evidence that impact in science can have these kind of exponential tail effects that may not look exactly like a linear 1 to 10 score. And so we wanted to try in our case to like actually formalize that and see what it would look like to try to score projects, incorporating the fact that tail positive outcomes are possible and even sometimes common in science. So what we did is we defined this kind of exponential mapping from a 1 to 10 impact score to a utility function that has a higher tail. And I think there are two ideas here. One is just to kind of like map on what we see in some scientific outcomes. And the second is to allow reviewers to really signify tail potential and to kind of shift the skew of review averaging such that like reviewers feeling very positively about a research proposal actually has the scope to pull an average up, rather than like the negative proposal or the negative reviews tending to drag an average down. So a clear example is that in a 1 to 10 score in this context, someone getting reviews of 4, 5, and 6 would do better than someone getting reviews of 3, 4, and 7 if you just use that 1 to 10 score and averaged. If you do this mapping to the utility space and then do the kind of averaging in that utility space and map back down to the impact score, someone getting a 4, 5, 6 would do slightly worse than someone getting a 3, 4, 7, because that 7 is signifying kind of a more significant positive outcome that pulls that average a little bit up. And so we in our study do this mapping up into the utility space to average and then back down into the impact space just for interpretability. So you'll see lots of 1 to 10 scores in the future of this presentation, but that's why. And then finally, as I mentioned, forecasting is the third kind of prong of what we were wanting to look at here. The general idea of forecasting is to take a prediction, like there's a probability of 25% that this outcome will be reached, and kind of define it in such a way that it can be very tangibly resolved, whether that prediction was true or false. So it requires you defining very specifically what it would look like to succeed at this scientific milestone. So then 5 years from now, you can say, was that prediction like, did that prediction resolve as a 1 or as a 0? And then you can measure accuracy of predictions, etc. So this creates this kind of learning loop that's displayed in this chart that looks a lot kind of like a scientific method. And this, we think, has some benefits in the peer review context. One is that it just incentivizes better predictions over time. Reviewers and other staff can kind of see where they are getting things right, where they are getting things wrong, and can kind of better target their own ideas about scientific merit and scientific feasibility. And second is that these estimates of reviewer accuracy can actually just feed into decision making, where you kind of know whether certain reviewers or certain topics tend to have a negativity bias, and you can kind of make adjustments, either personal or formal, to kind of better account for that in creating portfolios. So we think that's a very interesting context here. So just a few notes on the design of this pilot. So we focused in on 5 proposals. These are for kind of large scale, what are called focus research organizations, on the order of like $20 to $50 million over 5 to 7 years. This is a kind of scientific model that FAS has been thinking about and advocating for. So we had on hand several kind of pre-written proposals in this frame. So for each of these proposals, we worked with the authors and the scientists to define 2 tangible, resolvable milestones for their project that they thought represented kind of the goals of their work. And then we went out and recruited between 3 and 6 reviewers to go through each proposal and estimate for each milestone of each proposal the probability that that milestone will be hit within the kind of time frame laid out by the proposal itself, the scientific impact of that milestone were it to be hit. And we also added the social or societal impacts of that milestone were it to be hit, as that's an increasingly important component of a lot of peer review contexts. And then we also surveyed reviewers about the grant review process. And we think one of the key pieces of a feasibility study in any peer review tweak is how do reviewers experience this change? And we were sure to get that information. This was run on a platform called Metaculus, which is a kind of crowdsourced forecasting platform that implements the whole kind of technical backend of forecasting processes. And they were kind enough to host this for us, and were excellent collaborators in the design of resolvable milestone questions, which was tricky. So I want to start off with just what did reviewers think about this? Here's some positive quotes in green. The first one I kind of subtly bolded because I think that is a key one that we were hoping reviewers would feel, and we did see that it was the case. This reviewer says, I did like that a disentangled likelihood of succeeding by a certain time and impact were it to succeed. Often these two are taken together, and if one doesn't think it's likely to succeed, the impact is also seen as lower. So that's kind of a key piece that we thought was important to this expected utility framework, and it was great to see it reflected in reviewers' own experience. They enjoyed having those pulled apart and didn't feel like it was taking it away, that they couldn't kind of double count feasibility in the impact measure. Some folks were a little skeptical that it would be an interesting or valuable way to frame the problem, and found that it was, or that it encouraged them to think differently about kind of how the proposal should be evaluated or whether it should go forward. And some people kind of struggled with the probability estimation, which is very normal, and I think would be a key piece of any implementation of this at a larger scale. Some people did not like this, however, defined that in a very striking red. One person just said, I did not like this review process. They said it didn't allow expression of the key issues that'll enhance or prevent the likelihood of success. I think part of that is implementation. You could imagine doing this in a way where reviewers also have bandwidth to write as detailed cases for their probabilities and their impact estimates as they want to, and can factor that in a really formal way, and program officers are encouraged to use that information. Ours was a little more pared down, so it did kind of restrict the expression of those issues. Some folks just thought the forecasting didn't really add much over traditional evaluations. And the third piece is a key one about the design of milestones. This person thought that some of the milestones were a little bit vague, and could create some fuzziness in whether they were evaluated as having been hit or not. And for any kind of forecasting framework, that would be a really important part to get right. So that was useful to hear. So here are some of the distributions of the impact scores, and we did like a very small non-scientific survey of just what people thought like the average R01 that was funded would be on this kind of exponential scale. And you can see that these are kind of larger proposals than the average R01, and they, in general, get kind of notably higher impact scores, which makes sense. The impact scores for milestone 2 sensibly tend to be a little bit higher than for milestone 1. And social impact was rated a little bit lower, also sometimes higher than the R01s, sometimes not. And then we'll dig in a little bit deeper. So yeah, we pulled out 3 specific proposals here that we wanted to highlight. And I just want to kind of walk you through this table because it's a little bit complicated. So the columns show milestone 1 and milestone 2. Those each are 3 columns within. That shows the average probability of success that reviewers gave a milestone, the average scientific impact score. Again, this was kind of mapped into the utility space, averaged and mapped back down. Social impact score, then switches over to milestone 2, where those things are all rated again. So scientific impact and social impact were averaged to get kind of an overall impact score. And then the probability of success and impact of both milestones were aggregated to create this total expected impact on the far right column. So a few things to pull out. One is, as we expected and hoped, the probabilities of milestone 2 tended to be lower than the probabilities of milestone 1. That is desirable here because these were all kind of sequential milestones where the second one was designed to build on the first. So we wouldn't want a case where someone thought that the second stage of a research project was more likely to succeed than the first. Second is the impact conditional on success of milestone 2 tended to be higher than milestone 1, which, given that it's building on it and is expected to be kind of less likely to occur and more ambitious, also makes sense. And one thing, sorry, I didn't do all this highlighting. One thing I also wanted to pull out, it's very, very subtle, but it's an interesting example of what we think could happen in this framework, is that proposal 3 in that middle row was kind of dominated on probability by proposal 2 in the bottom row, where milestone 1 was about 20% less likely to succeed than milestone 2, or than proposal 2's, and its milestone 2 was slightly less likely to succeed than proposal 2's. But because it was rated as having slightly higher impact across both milestone 1 and 2, actually just milestone 1 even, a little bit higher scientific impact and notably higher social impact, aggregating that all yielded a total impact that was slightly higher for proposal 3 than proposal 2. And you can imagine in a traditional context, those subtle impact differences and the notable feasibility differences might lead to a different outcome. So we thought that was just an interesting case of that. There was one proposal not highlighted in the previous slide, that's row 4 here, proposal number 4 as well. That just highlights the importance of defining these milestones really carefully. This was a proposal where we defined the milestones in a way that we thought was sequential, but 1 or 2 of the reviewers actually rated milestone 2 as being more likely than milestone 1, which suggests to us that there was some ambiguity in whether it was truly a sequential or an independent set of milestones. And that actually affects what the total impact of the proposal is when you look at the reviews. So that's just like a key piece of this, is really defining those milestones carefully. And the other thing that we didn't do is communicate very explicitly to the reviewers how they were constructed and how the program or the project team saw the development of those milestones. You can imagine just kind of being explicit with reviewers that the project team will strive for milestone 1. If milestone 1 is hit, they will strive for milestone 2, and that can help reviewers come up with more accurate probabilities. One other thing to highlight is just across the board, scientific impact scores were higher than social impact scores. This is somewhat expected. These are kind of large scale projects that are kind of designed to be kind of socially impactful, but are also designed to like remove key scientific bottlenecks. But you can imagine having both of these, that depending on a program's priorities, you could weight differently, or you could kind of create separate total impact scores that feed into a different decision-making process. Just having both of these pieces of information kind of create a lot of flexibility in how you construct the impact of your portfolio, which we think is really useful. The other thing to highlight is the depending on the risk appetite that you bring to the table at your program, like a lot of these maybe don't fit the definition of high risk, high reward. Milestone 1 was by and large pretty feasible, between 50 and 90% probability of succeeding. Milestone 2 was a little bit riskier, but still in the like 40 to 50% probability range. And so this is a case where this information is actually just really useful for someone trying to shape portfolios, because you might come in with a different idea about what kinds of proposals you're getting and whether other scientists think that they are uncertain or risky or ambitious, and then see that actually when you estimate a probability of success, like these are things that folks think are pretty achievable, and you can kind of tweak that to create a portfolio that matches your own risk appetite. All right, so why might this be useful? High risk, high reward research is clearly a pretty important mission across a lot of organizations. So I pulled out some quotes from federal funders, internationally, from some philanthropic funders. A lot of people kind of have a desire to support risky research ideas, uncertain research ideas, ambitious research ideas. But there's kind of some uncertainty in how to do that. And I think one of the approaches that's kind of winning out recently is creating entirely new funding bodies or agencies or wings of foundations that are dedicated specifically to doing that work and use a separate organizational structure or set of mechanisms. That is definitely a useful approach, and we're big fans of a lot of the organizations that are being stood up to do that. But I think it's still really useful and interesting and important to think about how existing programs can factor some of these priorities, and in some cases, like commitments, into their existing work streams, and whether there are aspects of their own kind of core processes that can help reach high risk, high reward commitments. And so, yeah, I think approaches like the one described here, by all means, I don't think that the one we describe here is the end all be all. I'd be thrilled to kind of talk with you all about other approaches to achieving these goals that you think would be similarly or more useful. But approaches like this could kind of mitigate some of the risk-averse tendencies that I highlighted earlier, help folks advance their commitments, allow POs to have a better understanding and more shaping potential of their project and portfolio risk profiles, and create some of those learning loops that can improve the quality of reviews, improve program officers' insight into their own processes, and just like lead to better outcomes and decision-making over time. So what do we think is next in this idea and in others? I think pilot studies of similar or different approaches to measuring risk and upside in grant review would be fantastic. You could do this in ways that don't really change your own funding decisions by adding some questions about probabilities and upside and expected utility into your existing process as non-binding additions to a peer review survey. And then you could use some of these non-binding questions to kind of simulate how the portfolio would have changed had you used those for decision-making instead of using your traditional scoring system. And that can just provide a lot of really useful information without affecting the allocation of millions of dollars, if that's a step that one is not willing to take. And then we do hope that the end state is larger scale pilots where questions like this are actually incorporated into funding decisions and can allow for longer term study of project success rates and outcomes that can inform kind of that feedback loop, and even see whether folks treat their own application process differently, and are willing to be more ambitious when they know that feasibility is less likely to kind of drag their application down. This is less relevant to this audience, you're more of a funding audience, but we think there's also a lot of research that can be done in kind of partnership and academic context. So folks in the foundation or funding setting who have data on past proposals, you can imagine modeling or like bringing reviewers back to apply a new scoring system to past proposals and kind of estimating the potential effects that it would have had that way. And then more thinking on kind of what research success means, how milestones can be defined, would be really valuable. And I think that's something the foundations are well positioned to partner with academics on, given the various approaches that folks take to kind of progress reports and definition and components of an application that might touch on that. And then designing and calibrating impact metrics is another really interesting approach. So we took one approach with the exponential scale and with the combination of scientific and social, but there's no shortage of ways to think about kind of operationalizing scientific impact and creating a utility score that could be kind of ported into this broader framework. And I think that's still an open question that we're really interested in thinking more about. And I think in all of these contexts, collaboration between funders and researchers and asking and answering these questions is key, and is something that I at FAS and I at OpenPhil have been and continue to be very excited about, and would love to talk with you all about more. Thank you very much for your attention.